Good morning, Tahmina Khan is here in TKMATHS S1. In today's video, we will see the concept of composite functions. I have already made one video on this topic. The link is given in the description below. But now here, I am solving 4 different type of question with the concept of composite functions, domain and range. You can see here on this sheet, there are 4 questions. So I will make 4 videos, one on each question. And it will have all the parts of that question. So let's start with video 1, which has 3 parts of question number 1. So what you have to do in all 3 parts, you have to check and you have to state a reason why the composite function g of x is not existing. So this is what we will see in all 3 parts. So function f is given to you for a particular domain. I'm talking about part 1. Similarly, function g is given to you for a particular domain. So let's see why is it not existing. You can see function g of f of x. Now you need to understand few things here first before we move on. This is my composite function. This function is called inner function and this is called outer function. This inner one is also called first function and outer one is also called second function. So if I use these words, you should understand what I'm talking about. Now, inner function, which is the first function, is a linear function, 3 plus x. And we know linear function is 1-to-1 function. Domain is given to you, x greater than equals to 1. So, if I see here graphically, by the way, it is not required. I have just drawn it here to explain it better, right? Otherwise, you can do it without it also. So, when I see x greater than 1, I will substitute this value of 1 in the function. So 3 plus 1 is 4. So the corresponding value is 4. It means if x is greater than 1, the values of y will be greater than 4, which are on this part of the graph. Right? So how do we write it? We say for x greater than equals to 1, the range is equals to 4. So for inequality, it will be what? It will be greater than equals to 4. Now we know in the composite function, whatever is the range of inner function, like I got here range, f of x greater than equals to 4. This range becomes the domain of the second function. Domain. So what is the domain of g now? I'm writing it here again. The actual domain is x less than 3. It is given to me in the question. But what I am getting, x greater than equals to 4. So there is a big difference between x less than 3 and greater than equals to 4, right? So now because there is no common thing, that's why it is, I would not say common, rather I would say this f of x greater than equals to 4 must be lying 100% entirely inside it. Then I will say composite function is existing, whereas this is not the case here. So f of x greater than 4 is not in the domain of g of x, which is x less than 3. So g of f is not existing or is not possible. Let's see part 2. Okay, same question 1 but part 2. And we again will check why g of f does not exist, composite function. F of x is the same linear function. And for x less than 0, we will see what is the range for function f. Because the range of function f will become the domain of function g. Okay, so we have to find out the range of function f now for x less than 0. So here I have just written the question again. And I will substitute this value of x less than 0 in this linear equation. So what did I get here? F of x is less than 3. I have shown it through the graph also, a sketch also. Linear function I have drawn here for you. You can see here, this is my linear function. And x less than 0 means this side. So when I put x less than 0 or equals to 0 in the function, I got 3. It means the values of y on this part of the graph Why this part? Because x is less than 0. Are all the values of y which are less than 3, as it will go down. So the range of f of x will become the domain of g. Now you check. The domain given to you in the question is this, and you are getting this. Is this lying entirely inside it? No, it is not. It is saying x less than 3, whereas question is saying x less than 2. So purple line, the one we have gotten from f, has some values which are not in the original graph. The original domain given to us in the question. So this much extra is coming. So we can say the function does not exist. Some part of f of x, that is f of x less than 3, is in the domain of g of x, which is x less than 2. But of course, f of x is supposed to be entirely in the domain of g of x so that composite function exists. But it is not the case here. So that's why composite function will not exist. Okay, sorry. Now part 3 of the same question. I hope you will be able to do it by now yourself. Function f is linear function and function g is not a linear function. So we will check for x greater than -1, what is the range of the function? That range of the function should lie within this 100%. Only the composite function will exist. Okay, so let's see, is it the case or not? When I substituted x greater than 1 mean 1. Achha, by the way, sometimes the student get confused here. They said it is greater than -1, so we cannot put -1 here. We can, and the corresponding value I will get, I will not put equals to sign here, right? Because there is no equals to sign here given in the question. Okay, so my range for function f is less than 5. This range will be the domain of function g. But what is given in function g? What is the domain? X is less than 4. And what we are getting? Less than 5. So there are few extra things which are this part. So that's why we can say the function g of f does not exist. And you have to write reason every time. So you can say, though f of x less than 5 lies inside less than 4, but not entirely. And this is a condition. It must lie entirely within the domain of g of x. So thank you very much for watching the video. In the next video, we will solve example of question 2, the other parts. You can see the description link in the description below. Thank you. Take care. Allah Hafiz.